Hi, in this video we're going to be looking at Ohm's Law worksheet. And quick reminder, we defined Ohm's Law as being how much current flows through as being directly proportional to the voltage applied or the energy per charge, and divide that by the resistance of the device. So in your reference tables, it's actually listed as R equals V over I, because that's how we define resistance, as the relationship, the ratio between the voltage applied and how much current's flowing through. But I kind of like to write it out as this, just because it makes it easier. But this is the one they give you in the reference table, and we might as well finish off with the other one. If I cross multiply this, I can say that the voltage is equal to the current times the resistance. And so all of these are the exact same thing, just written out a slightly different way. Again, this is the one, I'll highlight it. This is the one that's in your reference table, so you probably should get used to seeing that one, but I'll probably use them interchangeably. All right, so if we look at the first one, it says a 9-volt battery supplies power to a cordless curling iron with a resistance of 18 ohms. How much current's flowing through? So again, we will guess. So we know that our voltage is equal to 9 volts. Remember, this is the one thing in physics that actually makes sense. Voltage is measured in volts. And that we have our resistance is equal to 18 ohms. And we're looking for current. That's my question mark. So I'm going to use I equals V over R here. So I'm going to take my voltage of 9 volts, divide that by my 18 ohms, and I'm going to get a whopping 0.5 amps. Now, if you don't remember that the unit for current is amps, that's okay. You could have also put down, I'll put this in green, you could have put in 0.5 volts over ohms, and that would have been perfectly acceptable as well, because we took 9 volts and we divided that by 18 ohms. All right, if we look at the next one, it says we have a 110 volt wall outlet, so we know the voltage is 110 volts. And it's going to power to a strobe light with a resistance of 2200 ohms. So my resistance is 2200 ohms. And again, they want to know how much current's flowing through. So my equation, same one as it was before. I is equal to V over R. So V is 110 volts. My resistance is 2200 ohms. And when I divide those, I get a whopping 0.05 amps. Or if you want to go scientific notation, 5 times 10 to the negative second. But the 0.05, that's perfectly fine. We look at the next one. We have a CD player that has a resistance of 40 ohms. So again, we guess resistance is 40 ohms. It has a current of 0.1 amps. And now we're looking for how much voltage is. Now it also asks us to sketch the circuit diagram. We'll talk about this really briefly. I've got my voltage source. That's what I'm looking for. Remember, this is my symbol for a battery or a voltage source. And then I have my conductors. It's going to come up and it's going to go into my CD player. Now, my CD player acts as a resistor. So I'm going to use the symbol for resistance. Now, it doesn't have to be pretty. Obviously, you see mine. Okay? And then it comes back around and comes back around in. So there's no switch. There's nothing. This is one of the simplest circuits we can do. We have our voltage source. We have a resistance, and so we can actually label it, oh, hey, here's my voltage. That's what I'm looking for. My resistance is 40 ohms. And the current flowing through, I'll change colors for that. Current flowing through, that's my I, and that's my 0.1 amps. So if we want to solve this for my voltage, and I'll put this back in red, my V is equal to I times R. So I know my current, that was 0.1 amps. And I know that my resistance is 40 ohms. And so when I multiply those two together, I get 4 volts. Right. Jumping down to the next one. Voltage of a circuit with a resistance 250 ohms. So R is equal to 250. And we know the current is 0.95 amps. And we're looking for the voltage applied. So this is the exact same equation we just did. So V equals I times R. So V is equal to 0.95 amps. And we're going to multiply that by a resistance of 250 ohms. And when we do that, we get a voltage of 237.5 volts. Next one down, how much current flows in a 110 volt circuit? So, okay, we're looking for current. I is my question mark. I know my voltage, they told me it was 110 volts. And it tells me that I have a resistance of 80 ohms. And so I need to find out my current. I'm going to go back to my original equation that I gave us all to begin with, that I equals V over R. Better R, there we go. So my voltage is 80 volts. My resistance, oops, sorry, I flip-flopped that, 110 volts. Divide that by my 80 ohms. And when I do that, I get 1.375 amps. Now, those are all pretty straightforward, pretty easy. We do have one more. It's a little bit more challenging. This is, what if I don't give you the resistance? What if you have to go find it first? Okay, and so I'm going to guess this one. I'm going to walk us all the way through it. It says a copper wire of, this scripty looking thing. This scripty P looking thing is what's called resistivity. We talked about this before. Different materials have different natural resistances to current flowing through them. So for copper, its resistivity is 1.72 times 10 to the negative 8th ohm meters. By the way, you can find a bunch of these in your reference table in the electricity section in the lower right-hand corner. It gives you resistivities of different metals. Lower right? I don't remember. I had to do a quick double check, but I was right. It's in the lower right-hand corner. So, of different resistivities at 20 degrees. Because remember, we determined that temperature makes a difference too. As temperature generally increases, so does resistance, and vice versa. So, we've got a resistivity of 1.72 times 10 to the negative 8th. We know we have a length of 160 meters, and we have a diameter of 1 millimeter. So 1 millimeter, and immediately I go, ooh, that's not good. I live in an MKS world, so I have to change that into meters right off the bat. So I went 1 times 10 to the negative 3rd meters. Now, the other thing they tell us is that we have a voltage, and I'll put this back in red, a voltage of 1.5 volts. And they want us to find the current. So I equals question mark. Well, we don't have a way to go find this yet because we don't have the charge in time. We don't have the, we do have the voltage, but we don't have the resistance. So we have to go find the resistance first. So in finding a resistance, I look for the other equation for resistance, which is that rho L over A, where rho is the resistivity. We have that 1.72 times 10 to the negative 8th. L is the length of the wire. We have that. That's 160 meters. And then A is for area, for the cross-sectional area. Now, I will tell you, you can make the bold assumption that all of our wires are going to be circular. So we need to find the area of a circle. So let's go find the area first. Let's put this in blue pencil. The area of my circle, again, if you don't remember this, that's okay. It's on your reference tables, but the area is equal to pi times r squared. And so I'm going to take my pi, and I'm going to multiply that by my radius. But I've got, I've got diameter, not radius. Well, I'll just chop it in half. So my radius, I'll put this in orange, my radius is 1/2 of that. So it's going to be 0.5 times 10 to the negative 3rd meters. Now, I hear a few of you going, well, wait, that's not proper scientific notation. Can you leave it like that? The answer is yes. They're not looking, this is a number that I'm going to use in the middle of my equation. It's not my final answer. So even if they asked me to put my final answer in scientific notation, I wouldn't have to do it for this part. So I've got pi, and now I'm going to multiply that by my radius, which is 0.5 times 10 to the negative 3rd meters, but don't forget to square that. And so when you do get that, you find that you have an area. Oh, you know what? I didn't find that. Hang on. Let me pause this. I'll get right back to you. Okay, I'm back. The area I calculated out to be 7.85 times 10 to the negative 7th. So you can check that to see if you got that right. And obviously that's got to be square meters, because our radius was in meters. So when we square, we get square meters. So now once we know that, we can plug everything back in. I'm going to put this in green now. My resistivity was the 1.72 times 10 to the negative 8th ohm meters. My length, they told me, was 160. I had that listed over there. And I'm going to divide that by the area that I just found. That's 7.85 times 10 to the negative 7th square meters. And so when I do that, I end up getting, I got to go back through. Oh, there it is. A resistance of 3.5 ohms. Okay, so that's a ton of work already, and yet we're not even done because our goal wasn't to find resistance. our goal is to find the current. So I slide back over here. It tells me that my I is equal to V over R. So I equals V over R. I can get rid of that question mark now because you don't need it. And so my voltage, that was that 1.5 volts. I know the resistance was the 3.5 ohms. And so when I divide those together, I find that my total current is 0.43 amps. And that's my final answer. Okay, so I hope that helps on Ohm's Law. And if you have any questions, again, take a look at some of the should-dos and come in and get some help. All right, everybody have a great night. See you later. Bye.